Let's talk about the sun, that giant ball of fire in the sky. It's a nuclear powerhouse, constantly radiating energy and fueling all life on Earth. It's the engine that drives our planet. Every single second it fuses hundreds of millions of tons of hydrogen, converting it into helium. This process releases an unimaginable amount of energy, a continuous stream of photons hurtling through space. Just a single hour of sunlight hitting the Earth's surface contains more energy than the entire human population uses in a whole year. Think about that for a moment. So the problem isn't the energy supply itself, it's the challenge of how we effectively capture this abundant energy and then reliably store it for later use. For centuries, we have relied on fossil fuels to power our civilization, ancient sunlight, trapped underground, now dirty, polluting, and ultimately finite. Now, modern solar panels offer us a way to directly tap into the sun's radiant energy, converting those photons into clean, usable electricity, without the harmful emissions. But the challenge is that sunlight isn't consistently available. Night inevitably falls, clouds gather overhead, and the seasons inevitably shift, impacting sunlight availability. Our energy needs, however, are constant. They never stop, day or night. Therefore, the real challenge we face is developing effective ways of storing solar energy, so it can be used anytime, anywhere, regardless of weather or time of day. Without effective storage solutions, solar power remains unreliable, a part-time player in the energy landscape. But with robust storage capabilities, solar energy can power our world around the clock, cleanly, sustainably, and reliably. That's precisely why bottling sunshine, mastering the art and science of solar energy storage, is so incredibly important. It is the key that unlocks a brighter, cleaner, and more sustainable future for all. So, how do we actually capture and store sunshine, transforming it into a readily available energy source? During the day, when the sun's rays are at their peak, solar panels often generate more electricity than we can immediately use. This excess energy presents a valuable opportunity. Instead of letting this clean energy go to waste, we store the excess in batteries, holding it for when we need it most. Think of them as giant rechargeable reservoirs, ready to release their stored energy on demand. The most common and effective solution for this? Lithium-ion batteries, known for their efficiency and reliability. These batteries are scaled up from the ones in your phone to power entire homes and even electrical grids. They store energy chemically, holding on to the sun's power. Then, they release it as clean electricity when the sun goes down, or whenever it's needed. This storage process smooths out the natural ups and downs and variability of solar power generation, ultimately making it a more reliable and consistent energy source. Our traditional electrical grid was originally built for steady, predictable power sources, and it wasn't designed for the variable output we see with renewable energy sources like solar and wind. Storage bridges that critical gap, absorbing the surpluses generated during midday, and then delivering that stored power during periods of peak demand, like in the evenings. It transforms solar energy from something unpredictable to a dependable resource, making the vision of a fully renewable energy grid a real possibility. Energy storage is the essential bridge, connecting those sunny days to dark nights, ensuring a continuous supply. It's ensuring clean, reliable power anytime, day or night. Lithium-ion batteries lead the charge today, powering everything from our smartphones to electric vehicles. They've become the workhorse of modern energy storage. But the quest for better, more efficient, and sustainable energy solutions never stops, and new storage tech is constantly on the horizon. Innovation is key to meeting our growing energy demands. Flow batteries, for example, offer a unique approach, storing energy in liquid tanks, a departure from traditional solid-state batteries. This design makes them easily scalable and incredibly long-lasting, making them a perfect solution for grid backup and large-scale energy management. They can cycle thousands upon thousands of times with minimal wear and degradation, ensuring a reliable and consistent performance over their lifespan. This robust cycling capability makes them exceptionally ideal for large-scale use, where frequent charging and discharging are the norm. Solid-state batteries, on the other hand, promise even higher energy density, potentially packing more power into a smaller space, and enhanced safety features. Gravity batteries offer a different approach altogether, using excess solar power to lift heavy blocks to a height, effectively storing potential energy. This stored energy is then released as they descend, converting potential energy back into electricity when needed. Pumped hydro storage, one of the oldest and most established methods, efficiently pumps water uphill to a reservoir and then releases it through turbines to generate electricity when demand surges. Other innovative solutions include compressed air energy storage, molten salt thermal storage, and the promising potential of hydrogen storage technologies. It's clear that no single solution will dominate the energy storage landscape. Instead, the future will be characterized by a diverse mix of technologies, each carefully selected and optimized to suit different needs and applications. The next era of energy storage is set to be diverse, incredibly innovative, and absolutely essential for enabling a truly sustainable and solar-powered world. The road to solar storage isn't without obstacles. Cost remains a major barrier. Large-scale batteries are still expensive. Lithium-ion batteries rely on scarce materials like cobalt and nickel, raising ethical and environmental concerns. As demand grows, supply chains will be strained. We need new chemistries using abundant sustainable materials. Batteries degrade over time, losing capacity with each cycle. Recycling old batteries is complex but crucial to avoid future waste. Our power grids were designed for one-way flow, not millions of distributed solar systems. Smarter software, updated regulations, and new market structures are needed to integrate storage. Overcoming these challenges requires innovation, policy change, and global cooperation. Imagine a world where solar innovation is transforming how we live, where new breakthroughs make clean energy more accessible than ever. Picture sodium-ion batteries powering entire neighborhoods, offering a safer, more abundant alternative to lithium. Imagine AI-driven grids that balance energy in real time, making blackouts a thing of the past. Perovskite solar cells are making solar panels more efficient and affordable, even in low light. And electric vehicles aren't just for driving. They can store energy and share it with your home or the grid. These innovations boost resilience, reliability, and open up new possibilities for everyone. Outages become rare, and your electric car can double as a backup battery for your home. Projects around the world are already showing how these technologies stabilize grids and lower costs. Which of these innovations excites you most? Sodium-ion batteries, AI-powered grids, perovskite solar, or vehicle-to-grid tech? Let us know your thoughts and questions in the comments. Your ideas could spark the next big breakthrough. Solar and storage together can end our reliance on fossil fuels, slash emissions, and clean our air. This is our best weapon against climate change, and a path to energy independence for everyone, everywhere. Bottling sunshine isn't just an engineering feat, it's a leap for humanity, lighting the way to a sustainable, stellar future. If you want to stay ahead in engineering and renewable energy breakthroughs, make sure to subscribe and join our community.